Okay.
Take it at that and don't even try to.
So, we're on 6.10. Problem number 1, page 219. Let me write that up here in case I have to go back later and fill this in. Now, if you want to figure out what they're doing here, you have to carefully read the directions and look at their example. The first thing that they're giving you here, they're going to call the first one the scale drawing. So whatever's in the first, on the left-hand side is the scale drawing. Fit all that in there. And then over here on the other side, this is the actual object. Okay, so if this is the scale drawing here and the actual object is on the right-hand side, that's how you have to look at all these to get their answer, because otherwise you get the opposite answer if you're doing it the way I was doing it. What is the scale drawing? Is it a reduction of the actual object or is it an enlargement? Okay, so your scale drawing is 1/8 of an inch. Your actual size, that 1/8 of an inch represents is 10 feet. It's what now? They say reduction. Here's how they're thinking. This is, the scale drawing is smaller than the actual object. So let me write that out. Scale drawing. This is so confusing. I was saying what you were. Okay. Scale drawing is smaller than actual object. So they call it a reduction. And I wanted to, I was getting all the opposite answers. So you have to look at it. They're always going to put the scale drawing on the left and the actual object on the right-hand side, okay? So you kind of, I actually, when I was doing these, I had to write it down like I did there so I could think through it because I was just kind of going, what, you know? So since the scale drawing is smaller than the actual object, their answer for this is a reduction. Let me pick one that's the other way around so you can kind of see how they're doing it, all right? Which one? 5. Yeah, 5's a good example. So if you look at 5, remember, this is the scale, and this is the actual, right, on this side. So they have 1.5 inch on the left, that's the scale version, and they have 1 inch on the right. So is the scale smaller than the actual object, or is it bigger than the actual object? And that didn't come out quite right. It's bigger, okay? So the scaled object is bigger than the actual. And so this is an enlargement. Do you see what they're doing now? You kind of have to break it apart and think about it more than you would think you would have to think about it, because you got to go, well, what are they putting on the left and what are they putting on the right? 4 would be an enlargement. We can look at 4. This, I know, I was like, I almost thought we just ought to skip these. But number 4, they have 1 inch on the left. Now that's the scaled object, right? So let's label it so our brains can process this. And the actual goes on the right. The actual object is 1/16 of an inch. So is the scaled object smaller than the actual object, or is it bigger than the actual object? Well, 1/16 of an inch is a little bitty piece of an inch, right?
Yes.
So it's actually, they drew it bigger than it really is. 1 inch is the scaled object. It's bigger than the actual object of 1/16. So this is an enlargement. Who else thinks this is a little more? Number 2, when they write 7 to 4, 7 is your scale, and your actual object is 4. So what would that be? It would be an enlargement because the scale is bigger than the actual. So that's an enlargement. They're just showing you all the different ways you could write. These type problems, you typically solve them with proportions, which is why I started off with that similar figure thing, because that's how we're going to be thinking in today's exercises. Okay, so number 7, what you got to do is use a ruler. And if you use a ruler and you measure each side, you're going to write each side down. For instance, I'll label in a different color. Here's what they say. Check out, let's say we're going to label this side. So measure that side really quickly for me and tell me what you get in inches. 1 inch, right? So this is 1 inch. And if you measure this top one here, Do you get 1.5 inches?
Yes.
Okay, so this is 1.5 inches. This is the actual, isn't it? Here. If you measure this other side, it's also an inch, isn't it?
And the bottom is a little more than
Okay, so here's what the book says it is. This book says it's 3/4 of an inch. See if you agree. Once you get them measured, they just want you to go and tell what size the scale, okay, if this is the scale, what would the actual object be? So here's what, let's do this with a proportion. 1/4 of an inch represents 3 feet. So here's what I could do. Here's my given. I'm going to write it this way. 1/4 represents 3 feet. I'm going to put the measurements in just to show you something that happens that you might not expect. Now, in real life, I say 1/4 is 3 feet. That's the given piece of information. That tells me how it's scaled, right? So over here, if I want to find, for instance, let's do the sides with 1 first because they're easier. If I measure, remember the top is going to be the scale and the bottom will be the actual size. So if I have 1/4 of an inch on a scale equals 3 feet, wait. There's a couple ways to set these up and I'm double doing it here. If 1/4 of an inch equals 3 feet, then what would 1 inch measured equal? We could call it x, right? Now if we cross multiply 1 inch, let me put that inch on there. 1 inch times 3 feet would be 1 times 3 is 3 inch feet, right? I'm going to show you that the units actually work out and that you can really ignore the units. This is what I'm trying to show you here. And if I cross multiply on the other side, I have 1/4 inch times x. That would be 1/4 x inches, wouldn't it? Couldn't I divide inches out of both sides now? I can divide units out just like I do numbers, okay? If I divided the inches out of both sides, those would cross out, I would end up with 3 feet equal 1/4 x. You don't have to do this on every problem. I'm just kind of showing you how this works because I know I was always confused and thought I had to get the same unit on the top and the bottom because I just, that could complicate things in my mind so much. If I'm trying to solve for x and I'm using a proportion, what would I multiply both sides by to solve for x, Jaden?
I'm confused. Oh.
We're in the middle of a problem. That's not, yeah. So what would I multiply both sides by? How do you get rid of a fraction in front of a variable? Yeah, it'd be 4. 4. Flip it, so it'd be 4. So multiply both sides by 4. And 4 times 1/4 would cancel out. I'd end up with x equal 4 times 3 is 12 feet. All right, what I want you to see here is this. I needed my answer in feet, and I got it, and it was in the right unit, wasn't it? Mm-hmm. So I can ignore the units and just go, oh, I'm trying to find the actual object. That's going to be in feet. That's why in math, a lot of times we just ignore stuff because we use proportions so much, and the units always work out that you're like, I don't have to keep up with them here because they're always working out. So I don't need to do all that inch feet stuff. If the stuff that's missing is in feet, I'm going to get an answer in feet with proportions. That's one of the other reasons proportions are so good, is that they help you solve stuff out easily. Okay, so this 1 inch over here, this is actually 12 feet. So that side's 12 feet, and that side's 12 feet. Now, if I got 3/4 of an inch, I could do this. I could say 1/4 of an inch is equal to 3 feet. So I'm going to build one proportion off this given information here, okay? Now, I want to know the actual, remember the scale is on the top, the actual side's going on the bottom. If I have, let's say I'm looking for this 3/4 side here, I could say, well, my scale is 3/4. What's my actual size? Let me just call it x. So now I could cross multiply. So we set it up with the scale on top and the actual on the bottom, right? Scale's on top, actual's on the bottom. I got a proportion, so all I got to do is cross multiply. 3 times 3/4 on one side, and on the other side 1/4 times x, right? Okay, so let me make this 3 into 3 over 1. Isn't the left side 9 over 4, right? Everybody okay with that? So I'd have 9 over 4 is equal to 1/4 x. You can probably see what the answer is going to be, but if you don't, how could you get x by itself? How would you get rid of the 1/4?
Do the 4.
Multiply by 4, right? 1/4, flip the fraction, you have 4 over 1. So that's what I'm going to do. I'm going to flip the fraction, and I have 4 over 1, which is 4. And the 4's cancel out. On the left-hand side, I'm left with x equal 9, and I know that it's feet that's missing, so I can just write feet on it. So I don't have to really keep it with my units here. I can just say, hey, the missing part was the one with feet, so it's going to be feet. So you don't have to do all that inch feet stuff I was doing earlier, but I wanted you to see that it does work. Everything crosses out, and you end up with what you need to have on your answer. Okay, so if it were 1.5 inches, let me go to the other side. Another 1/4 inch was equal to 3 feet. That was the given, right? So I'm going to make a proportion out of it. 1/4 inch is 3 feet, and I don't have to write the, I'm going to put inches and feet over here just so I make sure I'm doing the same on both sides. Now, we are still missing the one on the top. It was 1.5 inches, right? What is 1.5 as a mixed fraction? Because isn't that like 3 halves? 2 times 1 is 2, plus 1 is 3 over 2. Remember, we don't like these things in algebra. They don't work out so well for us. We're going to write this as 3 halves. And we don't know how many feet that is, right? So I can cross multiply and find out, because 3 times 3 halves, wouldn't that be 9 halves? And then over here I got a 4th times x, which is a 4th x. And how do I get rid of the 1/4 in front of the x?
4 over 1.
Yeah, 4 over 1. We just flip the fraction. That's 4. 4 over 1. These cancel out and leave me x equal, I'm going to reduce this before I multiply. 2 goes into 2 one time, and 2 goes into 4 2 times, right? What's 2 times 9? 18 feet. We got it. That's our answer there.